Lesson 9.3 will introduce us to solving equations by square roots. This is our third method. We solve by graphing, understanding that when we set it equal to 0, we can graph it and use the x-intercepts. And then we've solved it by factoring, but not all quadratics factor. So with a factor, that's a great method. Otherwise, we need some other options, right? Well, the same is true for solving by square roots. This might be my favorite, what I think is the easiest method when I'm allowed to use it. The catch is that it only works when b is 0. Okay, so I really can only get away with using this particular method when b is equal to 0 and I don't have the entire trinomial. That middle term is missing. Okay, but if and when you have this scenario, this is a phenomenal choice because it kind of solves the problem that typically quadratics bring up of, oh, how can I solve for x when I have two different x terms? Well, when that b is 0 and that middle x term is missing, the linear term that's degree 1, then there's only one x squared term, and you can just isolate that like we traditionally have done when solving equations over the past several years. So in this type of scenario, all you have to do is what you've always done, you know, like I said, since you were in 5th or 6th grade and you started solving equations. Get rid of the stuff around it, isolate that x squared using all of the inverse operations like we typically do. And then the only extra step that you would do here compared to what you were doing in the fall with regular equations is just take the square root of both sides so that you can cancel the power. Okay? Now, one thing to remember before we start practicing a few of these is when you do take the square root of both sides, you can only take the square root of 0 or a positive. If it's a negative value, then that's a no real solutions. So remember, and you can try that on your calculator, you know, all day, every day, and it's always going to give you that error message if you try to take the square root of a negative number. So I could come here, take the square root of a negative, sorry, that's not what I wanted to put. Let's try that again. Let's say I wanted to take the square root of a negative 9 here, and it's going to say, nope, you can't do that because you're trying to take the square root of a negative. So if you end up in that situation, you know it's going to have no solutions. If it's equal to 0, then it's going to have only one solution, add 0. And then if it's positive, just remember, and this is really the biggie here, is when you take the square root of a positive, it always has two solutions, the positive root and the negative root. Okay, so let's kind of put that into action here and do a few. We don't necessarily have to do a whole bunch on this one. But if we start here with number 1, I'm allowed to use the square root method because there's no middle term here. Compared to the standard form work that we were doing a few days ago, where there was 1, 2, 3 terms, that middle term right there is missing. And that's what allows us to use this square root method. So we would really tackle this like a regular equation. If I was trying to get x alone, what would I do? Well, I would get rid of that 49. So the opposite of a minus 49 is a positive. If we do it on one side, we have to do it on the other. And that would leave just x squared by itself is equal to 0 plus 49, which is just 49. And then really the only extra thing we do, because this is a quadratic, is then here at the very end, take the square root of both sides. Because I do have to totally get x alone, and that does include getting rid of that exponent of 2. So I know that taking the square root on both sides is going to cancel the power. And it's going to accurately let me isolate x. But what I want to remember is that the square root of 49 is both positive and negative 7. So there are two solutions. And if you graph this, then you would see it does still have two x-intercepts. It does intercept the x-axis twice. It intercepts at positive 7 and at negative 7, right? And so that's why if you only write, oh, it's 7, you completely left off one of your solutions. So make sure that when you can take the square root of that positive, that you give both roots. So our answer is that x is equal to 7 and negative, or if you want to write them together, you can do this plus minus, but make sure that you do include that. Okay, let's try the next one. Again, I see that there's no middle term here. That's great news. That means I can just isolate this and then take the square root. So to get x squared by itself, I'm going to subtract 64. That's the opposite of adding, is a negative or subtraction. That cancels. I get x squared is equal to 0 minus 64 is still negative 64. And then we have to get rid of the power, so we do the opposite, which is that root. Take the square root of both sides. That cancels that. We get x. However, even though 64 is looking really great, can I take the square root of a negative number? Nope. So this is actually no real solutions. So no real solution. Because when we go here to take the square root, we'd be taking the square root of a negative. You cannot take the square root of a negative. So that's a no real solutions. Okay. Take a look at number 3. If there's a number there, that's fine. We've done stuff like this before. Isolate the variable. Now you have two things you have to eliminate. Remember, we typically always start with the addition or subtraction first, unless there's a grouping symbol. So the opposite of minus 72 is to add 72 on both sides. That cancels it on the left, and now I've got 0 plus 72 is just 72. But then this one requires yet another step, because we also have to get rid of the 2. So since they're multiplying by 2, we are going to divide by 2 on both sides. That's what's really going to isolate our variable. 72 divided by 2 is 36. And then we still have to do that extra step that we didn't have to do earlier in the last few years, but we still have to get rid of that power. So at the end, we take the square root, make sure this guy's positive. Yes, we can take that square root because it's a positive number. So x is going to equal the square root of 36, which we know is both positive and negative 6. So that does have 2 roots. There it is. Okay. I'm going to try one more like this. And this one involves that negative in there, so I wanted to just show you that one. If you look here, again, we've got a couple of things to isolate, so we'll start off by getting rid of the 12. The opposite of that negative or minus is a positive, like that. So that gets rid of the 12 on the left side, and it leaves us with just negative x squared is equal to. And then on this side, it's going to be negative 12 and positive 12, so that also cancels, and it leaves us with 0 or nothing on the right. Then we still need to get rid of the negative, so we'll divide by a negative 1 to cancel out the negative sign. So now I've got x squared is equal to 0 divided by negative 1. 0 divided by anything is still 0. And then here at the very end, I still have to drop that square root, that power, that square, so I take the square root of both sides. That's what lets me cancel the power. So I get that x is going to be the square root of 0. Now this is the middle example. When d is 0, then there's only one real solution, which is going to be a 0. In other words, the square root of 0 is just 0 once again. And there's no positive or negative, it's just that one root. And if you were, that's the beauty, now that you understand that the solutions are the x-intercepts, if you're ever in doubt on any of these, you can graph it and confirm whether or not the answer that you got here is actually your x-intercept. Okay? All right, let's try one more. Let's try number 6 here. So if we try number 6, just to isolate once again, we want to get x alone. So we'll start off by moving the 16 with the opposite sign. The opposite of addition is a subtraction or a negative. Then we get negative 3x squared is equal to, and then over here these are both the same sign, so we find the sum. Negative 11 and negative 16 is a negative 27. Okay. And then next step is to get rid of the negative 3. Since they're multiplying, the opposite is to divide. So we get it is equal to 9. So negative 27 divided by negative 3 is a positive 9. And then last but not least, we take the square root of both sides so we can drop the power. X is going to be the square root of 9. That's a positive 9, so it can be, we can take the square root of it. It does have real roots, and it is both positive and negative 3. That's the square root of 9. Okay. All right. So try, let's see, let's have you try number 8 on your own, and then check to see how you do on that one. Okay, so check your work if you want to pause it so you can see the steps. I get all the way through here and I realize that really x is just going to be the square root of 16, which is a positive 16. And I can take the square root of that. the roots for that are going to be both positive and negative 4. So if that is what you got, then you're all set. And again, you could write that separated out, 4 comma negative 4. You could say x is 4 and x is negative 4, or you could do the double sign, but you do want to make sure you have both roots. All right, guys. So now let's talk here about how we might actually be able to use this same concept of the square root method, even if I have a binomial. This might seem a little bit like, not out of place, but a little different, but oh man, if you can catch this and understand this, it's going to pay off big time on our very next lesson called completing the square. So remember, when we had a perfect square trinomial, we could write it as a power. So just remember that, like when I had a perfect square trinomial, like maybe x squared plus 6x plus 9, that was a perfect square trinomial. We could rewrite that as the exact same binomial to the second power. That's a perfect square trinomial, which means it's the product of something times its identical self. It's the product of something squared. Okay, so that trinomial can be written as a perfect power, like this, in that power form. And then once you have it in that power form, y'all, we can take the square root of both sides. Since that whole thing is a perfect square, it's that number to the second power, then I can take the square root of both sides here, which allows me to drop the radical on the left side, the power on the left side. It leaves me with just what was inside, which is just that x minus 4. And on the right side, the square root of 100 is both positive and negative 10. Okay? So now I can solve this for x pretty nicely, but you've got to be careful here. You've got to remember you have two answers here. So at this point, I think it's really smart for you to kind of separate this out into two equations. So one equation that's going to be true here is going to be that x minus 4 is equal to positive 10. And then an equally accurate and correct answer is that x minus 4 will also equal negative 10. So I have to consider both options to find my two solutions. So in these types of problems, we'll take the square root to drop the power. That'll leave us with that x minus 4. When I take the root, I have to remember there are two roots that are correct and that work, and I need to set my little equation equal to each one of those and solve each one of those equations. So if x is positive, the right side here becomes a positive 10. Then when I solve this, x will be 14. So one of our solutions here is 14. If the right side is negative 10, then when I solve this, that solution is going to be a negative 6, because negative 10 plus 4 is negative 6. So the other solution here is negative 6. So those are the two intercepts, or the solutions to this quadratic. Okay. Let's try one more. Look at number 10. If we try this one here, again, this is already a power. It's already a base to the second power. So we can take the square root of both sides here and just drop the exponent. So that would leave me with x plus 2 is equal to the square root of 196, which I'm pretty confident is a perfect square. Just want to confirm, I believe it's 14, but let's find out. 196, yep, it's 14. So it's positive and negative 14. Don't forget that it has two roots. And therefore, I want to branch this out. So one of our solutions is going to be when that x plus 2 is equal to the positive 14. And the other solution is going to be when that x plus 2 is equal to the negative 14. Notice the x plus 2 part does not change. What changes are the 14s, because those are the two roots to that square root of 196. It's positive 14 and negative 14. That's the only one that switches signs on us. Okay, and then we can solve each one of these individually. So when I subtract 2 here to get x alone, I realize one of my solutions is 12. And over here, when I subtract 2 or do a negative 2 on both sides, I get my other solution as negative 16. What if it has a coefficient in front? Great question. So we want to make sure we isolate the power before we take the square root. Just like on the front page, we wouldn't have taken that square root until we had divided the 3, right? We want to isolate that power before we take the rule. You know, we didn't say, oh, square root of negative 3x squared. No, we divided by the 3, and then once this was by itself, then we took that square root of that x to the second power. Same thing here. I don't want to take the square root with that 16 in front of it. Let's go ahead and divide it. Since it's being multiplied, the opposite is to divide on both sides by 16, so that the power, the part that has the exponent, is by itself. On the other side, that doesn't go in evenly. Do not even hesitate to leave it as a fraction. And in fact, if you're starting to see ahead that I'm about to have to take a square root and that these are perfect squares, you're going to realize how lucky you'll be if you do leave it as a fraction instead of dealing with a decimal. So we're going to now that it's by itself, we'll take the square root on both sides. That drops the power. And we get x minus 3 is equal to the positive or negative root of 25 over 16. But we know the square root of 25 is 5, and we know the square root of 16 is 4. So it's positive and negative 5/4. Okay, and then we do just like we did up there. We set up one equation where it's the positive 5/4 and the other equation where it's negative 5/4, and we solve each one of those. So to solve it, we would add 3 on both sides, add 3 on both sides, and maybe a decimal would have been better. Who knows? I'm a fraction person, y'all know that. But either way, you can grab your calculator if that helps, and we can say, all right, so we've got 5/4. Oops, that's not a 4. And we are adding 3 to that. So that's one of your answers, is 4.25 or fourth. This one's user's choice. You could do decimal or fraction. And the other one is negative 5/4 plus 3. So that's our other answer, 1.75. And if you left those as fractions, that is okay. Okay, here's number 11. Okay. Now, that was awesome, but, you know, everything we did there pretty much, except for like this very last step, but really even that one, we all had really nice perfect squares. That's not always the case, okay? So I just want to remind you that your calculator is your friend as you're working through it, but when you're leaving in Simplified Radical, it's going to be less about the calculator and more about what we learned in that previous unit. So if you were like, I still don't understand why we did that radicals unit, now you know why. Because we want to leave our answer in Simplified Radical. So let's try number 13. Steps are the same. I don't have that middle term, so I can solve for x squared here. And I'll do that by doing a positive 12 on both sides. And I'll get x squared is equal to 15. And then I know that the next step is simply to take the square root on both sides. What's different now is that 15 doesn't come out nice. It does not play very nice with us, right? This will cancel that. But this is not a perfect square like we've been lucky enough to have. So the question as usual is, if it's not a perfect square, does it have any perfect square factors? So I think about what goes into 15, but it's only 5 and 3. Those are not perfect squares. So instead of going to a really intricate decimal there, I'm just going to say, you know what, since this doesn't simplify, I'm going to leave my answer in a nice, clean, exact way. It's the positive and negative. Don't forget, you still have to do that. It's the positive and negative square root of 15. And you can leave your answer just like that. Okay, let's try number 15. So again, we're solving. We want to isolate x squared, so we start off by moving, oops, that should be a minus. A negative or a minus 5 there. Ignore that sign. Should be a minus. That cancels that guy. So we got 6x squared is equal to 20, and a negative 5 is 15. And then we divide on both sides by 6. And we get, I'll write it over here, x squared is equal to 15 over 6, but I know 3 goes into both of those, so it's really 5 over 2. And then we take the square root on both sides to drop the radical, just like that. And we get that x is equal to the positive and negative root of 5 over 2. But then we want to make sure that's fully simplified. We would not want to leave a fraction inside a radical. So we would need to separate these guys out. And then we wouldn't want to leave a radical in the denominator. So we would need to rationalize this denominator. Okay. And that would leave us with square root of 10 over the square root of 4. But the whole point of that is that the square root of 4 is just 2. And that's the simplified radicals. So x is equal to the positive or negative square root of 10 over 2. And that's why we did that. So instead of dealing with a really terrible decimal. Okay? All right, let's finish off with a word problem. A ball is dropped from a window at a height of 81 feet. The function negative 16x squared plus 81 will represent the height, so this is height, okay, of the ball after x seconds. So this is seconds. Sometimes it just helps to kind of identify that out. How long does it take for the ball to hit the ground? So we want to know, does it take? That's a dead giveaway that what we're looking for is a value of t, or actually x in this case. They called it x. Okay, so a value of x, we're looking for that. We're solving for x. And then if they're solving for x, I hope they gave me some information about what I can plug in for height. Well, they said when it hits the ground. Well, if this represents the height of the ball and I'm on the ground, then that means that my height is 0. If I'm on the ground, then my height is 0. So once I kind of worked that out, I just realized, oh, so really I just need to take the function they gave us and set it equal to a height of 0, because that's when we will be on the ground, and solve this. Okay, and again, because it doesn't have that middle term, I'm allowed to use this square root method. So we'll move the 81 we'll end up with negative 81 on the right side. Then we'll divide both sides. Always isolate your power before you take that square root. So now we have x squared is equal to negative divided by a negative is a positive, and it's 81 over 16. I know that doesn't divide evenly. I also can see they're perfect squares, so I'm going to leave it just like that, because in a moment I'll then take the square root of both sides to realize that I have two options here, positive and negative. Square root of 81 is 9, and square root of 16 is 4. Now, two things. As much as I love fractions, when it comes to word problems, a lot of times decimals make more sense. And I have to admit, begrudgingly so, that it does make more sense to express the amount of time, how long it's going to take, as a decimal. So it's going to take 2.25 seconds. The other issue is that even though technically there are two solutions, and if we graph this, there would be two x-intercepts, one of these is not real life logical, right? So remember, once we start talking about word problems, we need to think about what is the logical answer. So even though there's really two quadratic solutions, in the context of this, really only the positive one makes sense. We haven't learned how to time travel and go back in time. We don't have a negative time concept. So how long does it take? It takes 2.25 seconds, and we would ignore the negative root on that one. Okay. All right, we'll do number 18 together in class, and that's your lesson on square roots.